Welcome to Minute Math. Today we'll be going through a very important topic, known as vectors. This sheet summarizes what you need to know for vectors. Let's start. So a vector is a quantity, with both magnitude and direction. So we can often express a vector, right? In this case, for example, vector AB. We can express vector AB in this form, right? As a column vector, right? UV, or we can express it as this form, right? This is also known as a vector. So in this case, this is how we express vectors. We can also delve into the magnitude of a vector. The magnitude of a vector is square root of u squared plus v squared. On the diagram, it just means that with reference to point A, right, point B is just u units and v units away, right, from point A. It depends the value of u and v, right? If u is positive, right, and v are positive, if both are positive, it means that b is rightwards and upwards, right? This may change depending on whether u and v is negative or positive. Next. So this is u squared plus v squared. Now, I would often like to disregard this portion, because I feel that it's a better way for me to explain this. So let's say if I give you any vector, let's go back to vector AB, right? I can often express vector AB as A something plus something B, where that something is a point, which I can decide. So for example, it can be AC plus CB, AD plus DB, any point, any third point which I can decide for myself. So let me give you an example. Let's say if in this parallelogram, right, as seen, I want to find the value of AD, right? So AD is, let me think of another point. So maybe AC plus CD, right? But let's say if the question gives me CA and not AC, I can reverse it. Make sense? Because AC is the negative of CA. This is always true, right? If I swap the alphabets around, right, the vector will be the negative of the other. Make sense? Because it's in the opposite direction, but of the same magnitude. Alright, let's do the next portion here, scalar multiplication of vectors. If I can express a vector, let's say AD, as KEF, right? What does it mean? It means that AD is parallel to EF. Makes sense? Because if I express in this form, it means that the two vectors are pointing in the same direction, but may not necessarily have the same magnitude, right? They only have the same magnitude if I equate them to be exactly the same. Alright? So in this case, you'll see that if k is positive, they are in the same direction, else they are in the opposite direction. Now, for position vector, this position vector has a very important meaning because it means with reference to a particular point. So let me give you an example. In this case, this example says that I want you to tell me what is the position vector of P with reference to a fixed point O. And that can be known as O vector OP, right? And if I tell you that the position vector of P, is let's say P comma Q, then I can subsequently deduce, right, that vector OP is PQ and the coordinates of P are P comma Q, because the only way for this to be possible, right, with reference to the point P, right? With reference to the origin O, right? Of the position vector of point P, you'll see that this is P units away and Q units, right? In the y direction, P units in the x direction, and this I can represent as OP to be PQ. Okay, so if the question says, oh, can you tell me what is the position vector of Q, right? If point Q is 2, 3. That being said, the position vector of P, okay, or Q, where Q is 2, 3, will mean that vector OQ is 2, 3. Make sense? Alright, now, since we're in the talking about column vectors, you need to know the operations. The operations of column vectors are just as follows. Okay, nothing much. Okay, is literally you just add the x coordinate of the vector, right, and the y coordinate of vector accordingly, right? We're adding two vectors, and similarly for the subtraction, as well as multiplying a scalar in to both the x and y coordinates respectively. Okay, so nothing too special about it. Okay, the next point is quite important. How do we prove parallel lines? Okay, to prove that two lines are parallel, it is better to use the vector. Okay, the vector that describes these two lines. Okay, so if I want to say these two lines are parallel, I just need to express the vector AB as a scalar multiple of vector CD. Okay, vice versa also works. Okay, so this means this can tell me two pieces of information. It can not only tell me the fact that AB is parallel to CD, it also can tell me how many times longer is AB compared to CD. Okay, in this case, AB is K times longer than CD. Take note, I don't say I said AB, which is the length, right? The length is K times longer than CD, right? Because I'm not talking about the vector here, I'm talking about the length, right? I'm also talking about the fact that both lengths are parallel. So if I can express a vector in terms of scalar multiple of another, it just means two things. The two lines, right, the two lengths are parallel, and I can also say that the magnitude, okay, or how long the length of one line is in terms of the other. Alright? Now, the next concept is also quite important, tasking about collinearity. So collinearity is a very important concept that you will see quite a lot because it allows you, okay, to state whether the points, right, are actually lying on the same straight line. That is the meaning of collinearity. Okay, whether the points are lying on the same straight line. How do we prove collinearity? Okay, often collinearity has to do with 3 or more points. Okay, and it is also using the same parallel line method which I talked about earlier. Okay, what is the difference is that in the earlier case I actually said that vector AB is K vector CD, right? In this case, instead of using KCD, I will actually make sure that one of these points here overlap with one of these points that I've mentioned here. Okay, so like for example, I can say AB is equals to KBC, right? B is being overlapped. Okay. What can I conclude about this? I can not only conclude that AB and BC are parallel, in fact they lie on the same straight line because there is a common line B, right? Because let me draw a diagram to illustrate this. If this is AB, apologies, this is AB, and I said that AB is parallel to BC, the only way this is possible if they all lie on the same straight line, right? I can't write it like that, I only can represent it like that, right? So these two mean the same thing, okay? And these two, okay, just is able to tell me that the 3 points are collinear. Okay, so that's all you need to know about this topic on vectors. Hope that you find it useful. Okay, in the subsequent video of Minute Math, we'll be going through some practice question on vectors based on what we have discussed here. Hope you have enjoyed this video. Please like, share and subscribe, and ring the notification bell if you would like to see more of such videos. Thank you.